Afternoon, everybody. My name is Greg Moeck. I work for a company called Strobe, and they sent me here, so I wanted to just express a bit of gratefulness to that, and also tell you that if you guys are building any JavaScript application that is talking to a backend, just basically as an API, I would encourage you to check out Strobe. It basically allows you to deploy the application to the web, Android, and iOS, just with a simple Strobe deploy command. So check that out if you want. And this afternoon, or I guess it's still morning, I'm going to be talking about why you don't get mock objects. So first, matter of introduction, a little bit about me. First thing you need to know is that I am not a primary teacher. Now you might wonder, what the heck is that? But I am a secondary teacher. Let me explain what I mean by that. There's a quote from Mortimer Adler in his book, How to Read a Book, where he says this: "The secondary teacher should regard himself as learning from the masters along with his students. He should not act as if he were a primary teacher, using a great book as if it were just another textbook of the sort one of his colleagues might write. He should not masquerade as one who knows and can teach by virtue of his own original discoveries. The primary sources of his own knowledge should be the primary sources of learning for his students. And such a teacher functions honestly only if he does not aggrandize himself by coming between the great books and their readers. He should not come between as a non-conductor, but he should come between as a mediator, as one who helps the less competent make more effective contacts with the best minds." And so when I say I am not a primary teacher, but rather a secondary teacher, I mean this. I am not an expert on mock objects in the sense that I developed them or come up with anything new, basically, in this talk. Basically, everything I'm going to say is something that somebody has said before, probably better than me. The only difference is that they probably said it in relation to Java. This is the book that I think is probably the best book on mock objects. And if you haven't read it, you really should go and get it. It's called Growing Object-Oriented Software Guided by Tests by Steve Freeman and Nat Price. These guys are the primary teachers. I'm just going to try to bridge the context today into Ruby. Secondly, let's talk a little bit about mock objects. Now, the Ruby community plus mock objects equals what? Love? No, not really. Mock objects have been called the following inside of the Ruby community: wastes of time. If you are using mock objects, you are wasting your time. They have been called scams. It's like somebody's trying to pull the wool over your eyes. And my personal favorite, testing heresies. If you are using mock objects, you are a heretic and you deserve to be burned at the stake. Okay, maybe not quite that strong. But still, that seems to be the general reception within the Ruby community. Now, why is that? Generally, people give two reasons as to why they don't like mock objects. The first being that they duplicate implementation. So here is an RSpec example from a talk that was given at RubyConf in 2008. And you have describing a show controller. And it says, when a TV show has no public videos, it should not display any shows. And in order to do that, it uses should receive all on the show object with select ID name, video count, condition shows.videocount equals 0, and return an empty array. And then it does the rest of the test. And then you come to the implementation. And oh, look, show all, select ID name, video count, conditions shows video count greater than 0. You see that part right there is exactly duplicated in the implementation. And they say, well, this is stupid. If I want to change anything about this, I'm going to have to change both the tests and the implementation. I'm just duplicating the system under test. Seems pretty bad, huh? Second, I've heard it argued that it leads to brittle tests that do a poor job. So for example, this is from the RSpec book, written by David Chelimsky, and it's describing a codebreaker game. And it says, when the game starts, it sends the welcome message. And in order to be able to do that, it provides a mock object doubles as the output. It says the output should receive puts with welcome to codebreaker. And then it says game.start. And then you come into the actual implementation, and you've got the same sort of thing, output, puts, welcome to codebreaker. But imagine we were to refactor this. Instead of using puts, we use writes. That would be the same from the end user perspective. And yet, guess what happens? If you change that, the tests fail. Oh, wow, that's stupid. I mean, the end behavior is the same. Why would I ever use these? The output doesn't change. QED, right? End of story. Mocks suck. Well, maybe. Or maybe you just don't understand them. In fact, actually, there was a talk that I was going to give on clean RSpec at the LA Ruby meetup. And I was going to slam on mock objects pretty bad because I thought that they did exactly these sorts of things. And then I stopped and I said, this seems so obvious. If this is how mock objects are supposed to be used, why would anybody ever have invented these pieces of junk? And I said, okay, well, maybe I just don't understand them. So I'm not going to slam on them until I understand them. Which, by the way, just a piece of practical advice, is usually a pretty good idea. When smart people invent something, and then you think, hey, man, this is so stupid, don't say that to anybody until you actually understand it. Then if you want to declare it stupid, that's fine. But make sure you understand it before you start talking, or you're going to end up looking like a fool. Okay, so why then would we use mock objects? Let's talk about that a little bit. The first thing I want to say is that mock objects plus procedural programming is a bad idea. Almost always. First thing relating to that, mocks are not stubs. Now, I hear a lot of people talk about, well, I'm just going to mock out that object, because mock objects are the way that people generally have done that. But there's a subtle distinction between what is a mock object and what is a stub. Mocks assert on messages that go between objects, whereas stubs return a value. So a stub is going to say, when you call this method, give this value back so that I can assert on some state within the object. A mock is actually designed to get in between the two objects and allow you to assert on the message going between the two. So for example, here in this show controller, this part right here is really a stub. Now there is an expectation on it because it has a should receive, but the point is that when I call this method, I want it to return an empty array so that I don't have to talk to the database or whatever. And you can tell that this is actually a stub and not a mock because you're actually asserting on the body. It's asserting on state. When you're asserting on state, you're stubbing. When you're asserting on messages between objects, you're mocking. So mocking plus procedural programming is a bad idea, but mocking plus OOP is a good idea. So the key idea in object-oriented programming is objects tell objects to do things. Now, I know we don't write our code this way a lot inside of the Rails community, at least, but I think we're moving in that direction a little bit. There's been a lot of chatter on the blogosphere and on like the Ruby Rogues podcast lately about moving towards object-oriented programming, more of a tell, don't ask sort of style. And this is what Alan Kay had to say about object-oriented programming. How many of you know who Alan Kay is? Okay, that's encouraging. For those of you who don't, he's the inventor of Smalltalk and kind of the guy who coined the idea of object-oriented programming to begin with. And he says this: the big idea of object-oriented programming is messaging. That is, what the kernel of Smalltalk or Squeak is all about. The key in making great and growable systems is much more to design how its modules communicate rather than what their internal behaviors should be. So for example, this might be internally what your system would look like. The circles represent objects, and the arrows in between are the messages that they send. hey, do this, hey, do this, hey, do this. And what Alan Kay is saying is that the key important thing in growing object-oriented systems is not to worry about what is contained inside of the objects, but to worry about the messages that go between them. That it is inside of the messages of an object-oriented program that the meaning or the domain logic of the application is truly found. So, for example, to change the behavior of a system, we compose objects instead of modifying methods. So let's look at a contrived example, see if we can see what I have in mind here. Imagine that you have a ticket machine interface. Maybe it's like an ATM. You've got a bunch of buttons, and you're going to type in the number of tickets that you want to use. Then you're going to push submit. Okay? And you've got this ticket machine object, and you've got a ticket reserving system. You're going to say, hey, I pushed, this number and then this number. Then I pushed submit, and it should reserve those tickets for me. Imagine if you wanted to save the requests before sending them. Okay, you have this object. It manages the interface. You want to save the request, maybe to a database or something, before you send the request. In procedural programming, how would you do that? Well, you'd go to the method that does it, and you would add code to that method. You would insert, okay, before you do this, you're going to add this code, and then you can do what you were doing before. Whereas object-oriented programming says once an object is complete and it does what you want it to do, in order to modify its behavior, you shouldn't have to change the object itself. You just change the object composition. So for instance, you have the ticket machine interface, and it still is reserving tickets, but you put another object in between the two objects to persist the ticket requests. And then it calls the same API on the ticket reserve system. And this enables you to not have to change the code that you already know is working. You just change the composition of the objects. So what would code for this interface look like? Maybe something like this. You have the ticket machine interface. On initialization, you have a request handler, and you store the current display. When a number is pressed, you add that number to the current display. When delete is pressed, you drop off the last number that went on. And when you submit the request, you tell the request handler to reserve a current display to I. To those of you who are not used to working in more of an OO style, this might be a little weird, but this is basically how tell, don't ask, well-encapsulated code works. And there are two things that you want to notice about this. First, it follows the tell, don't ask principle. Notice everything is the object is being told things. Hey, this number was pressed. Delete was pressed. Submit this request. So it's following tell, don't ask. It's not asking for information out of the objects in order to make decisions based off of that information that it gets back. It's telling the object certain things have happened or to do certain things. Second, notice that it hides its internal state. What is the internal state here? It's that current display. Whatever is currently being displayed is what this object is encapsulating and hiding its data for. And notice that there are no getters on this object. There's no way really to get at this current display, except in Ruby this actually does return the thing, right? But it's supposed to be a command, not a query. And so now all of a sudden, we've got this internal state that is completely hidden, and we have no ability to access it. Which leads to a question. How could you write a unit test for this code? We usually, when we do TDD, we think of it in terms of I call an API, it's going to change the state on the object, and then I'm going to assert that this state is now this, that it did what I expected. But if I'm hiding all of the internal implementation of my code, how would I test this? Can you assert on the state? No, you don't have access to the internal state. And by the way, that's a good thing. If you don't think it is, you should read up on information hiding. It allows you to build complex APIs that you don't have to know the implementation of. All you have to know is its API in order to be able to use it. It basically becomes a black box, an abstraction. All of us expect that of our libraries. Can you imagine a library that you had to know the internal details in order to be able to use it? but we don't generally expect that of our own code base. But when we start moving in that direction, hiding the internal implementation of the object, we no longer can see its internal state. We can only see what it does. And so how would we unit test this? Well, one method that's been proposed is just add getters for the tests. I don't really think that's a good idea. Because when you start modifying and adding special paths into your code just in order to be able to test it, you're not actually operating on the path that your code is going to run in production. It seems bad to me. So then how would you do the test? Well, remember, this is kind of our picture. We have this ticket machine interface, and these objects are telling each other to do things. So what if, instead of actually using a real ticket reserve system, I replaced that ticket reserve system, or I guess I don't have the ability to get into the test, but I can assert on the message going between the tests. Kind of like Alan Kay said, the key thing is the messages going between. And so I can assert on the message that the ticket machine is telling the ticket reserve system. So how would I do that? Well, instead of using a real ticket reserve system, I'm going to replace it, pass it into the constructor with a fake object. And this fake object is what we call a mock object. And so my test would look something like this. My request handler should receive reserve with 55. And you see I'm passing that request handler in the place of that ticket reserve system. You see, I'm replacing it with a mock object, a fake. And the responsibility of this mock object is to record every message that is sent to the object so that I can then assert on those messages that were sent. And so I say, hey, mock object, this is my assertion. You should receive the message reserve with these parameters passed to it. And that's the assertion on the message going between the two objects. And then I call the public API. I pressed 5, and then I pressed 5 again, and then I press the submit button, and that should send the message reserve with the number 55. Here's the key idea. In OOP, behavior is found in the messages. And so we don't want to assert on the state of an object. We want to assert on the messages going between the objects. And in order to be able to do that, we replace real objects with fake objects, or mock objects, in order to be able to assert on those messages. Okay, so having said that then, it takes a little bit of a change of mindset in the way you do programming. Honestly, if you just are doing a Rails application that you are doing things procedurally, odds are mock objects are not for you. It's kind of like this, okay? If you wanted to bang a nail into a piece of wood, you want to use a hammer. A screwdriver might work, but a screwdriver is not designed to bang in the nail. You want to use a hammer, which is generally assertions on state when you're doing a more procedural flow. When you are hiding your information, encapsulating it, and telling other objects to do something, then you pull out the tool called the mock object, because that's what they're designed to be used for. So let's talk a little bit then, knowing that, about some key mocking rules. And I'm taking all of these from Steve Freeman and Nat Price over the years. So again, I am completely not unique or interesting. The only difference is that I'm using Ruby, whereas they are using Java. So the first rule is mock roles, not objects. What do I mean? Well, here's the paper that they wrote for OOPSLA in 2004, if you want to look it up, that's actually entitled Mock Roles, Not Objects. And the basic gist is wanting to mock concrete objects is a design smell. That is, it's telling you the implementation of your actual code has a problem. Why? Because well-designed objects don't know explicitly who they are talking to. Why? Because who they are talking to can change. They should only know the role that their collaborator is playing, not the concrete object which they are talking to. So for example, in our ticket machine interface, this role on the right side that the ticket reserve system is playing is maybe called the ticket machine request handler. It handles requests from the ticket machine. The ticket machine doesn't need to know that it is particularly talking to a real ticket reserve system. And in fact, if you know that you're talking to a real ticket reserve system, you can't do something like this. You see, now I've changed the composition of the objects, and now instead of the ticket reserve system playing the role of the ticket machine request handler, my persist ticket requests object is playing the role of my reserve or my ticket machine request handler. And from the perspective of the ticket machine, I need to not care what the actual object is doing when I send it the message. All I need to know is what are the roles that the potential collaborators are playing so that I can tell them to do something and then let them carry out their things. And so when mocking roles, TDD becomes a design process. Not merely about asserting that the behavior is correct, although it does that too. It becomes a question of what are the roles that my collaborating object should be playing. That is, what doesn't belong internal to my object. So for example, if I start with just a ticket machine interface, and presumably I have come to this interface through some form of TDD, so I already know what role it's playing because I know that there's going to be an object sending messages to it. So I start with this. I know it's going to have number pressed, delete pressed, and submit request. What do? Well, I'm going to come up with a scenario that is going to demonstrate the domain logic of this behavior. It reserves the correct number of tickets when a number is pressed 2 times before submitting. And I would say, okay, here's a scenario, kind of like what Jim was talking about earlier. Given a ticket machine interface, when I press 5 twice, which is machine number pressed 5 times, and then I submit the request, what would be the proper behavior? And then I ask myself, okay, does this behavior that it's supposed to do, is this really behavior that belongs inside of my ticket machine interface? If it's following the single responsibility principle, an object should have one and only one reason to change. I don't want to actually put the logic for handling the request in the same place that I'm going to put the logic for handling the interface. Those belong to 2 separate things. And so I say, okay, what is the role that the collaborating object here needs to play? Well, I need whatever object I'm going to tell to handle a request when I am ready to send one. And so I create a mock object. Not an actual object that is going to be implemented, but a role that that object is going to play. Particularly here, it's the request handler. And I'm going to say, okay, what behavior should I tell this object to do? I should tell it that it needs to reserve 55 tickets because I pushed 5 twice. And then I told it to submit the request. And then I come back and I say, okay, I have this role, so I need to pass it into my constructor. I add it to the constructor, and I know I'm going to submit my request. I'm going to do request handler reserve, and I'm going to need to send it whatever the current display is. Now this should start to feel like TDD to you. Hey, wait a second. Okay, I'm sending the current display, but I'm not doing anything with the current display yet. So if I want to get it to actually send the right message, I have to implement the number pressed API so that it is storing whatever the current display is as it goes along. And so I add an internal state current display, and I say number pressed. When that happens, add that to the current display, and when I send it, I want it to be an integer. By the way, you'll notice this is not complete code, because if I were to just immediately push submit request, what's it going to send? An empty string 2i. Guess I need more test cases, right? But you see, this is the same sort of thing in the way that you do TDD normally. The only difference is you're asserting on a message instead of asserting on the state of the object. And what you end up doing is you end up getting a more decoupled system, because now you're talking to a role. And you're following this. It helps you to follow the single responsibility principle. as well as a bunch of the other solid design techniques. So the first thing is mock roles, not objects. The second rule is only mock types that you own. Now in Ruby, we don't really have types, but the idea, I think, still holds. Here's two references. I put these in primarily so that if you want to look at the slides afterwards, you can look them up. And here's the basic rule. If you don't own the API, there is no design feedback that you are going to get by writing a test for it. Instead of mocking a role, what you are really mocking is an implementation, because you don't own the API and you can't form it into whatever the role is going to be played. And so what you end up doing is you end up duplicating your production code in your test, which is a test smell. That doesn't mean you should never do it, right? It just means when you smell it, you should go, do I really need to do this? And so this means don't mock boundary objects. What do I mean by that? Here's the example that we talked about earlier in relation to the Codebreaker game from the RSpec book. And by the way, when this came up on a blog, Dave Chalimsky actually said that this is the way you should do it. So I'm not necessarily critiquing David. But here is the example, right? And inside of the Codebreaker game, what you're doing is you are sending a message to puts, right there. And we're sending the message output to puts. What's the problem with that? Well, we're coupling that to the actual standard output. We're saying the responsibility of this game is to talk to a command line interface. So it's specifying more than it needs to. It's handling the starting of the game as well as specifying what the object it is talking to is, instead of specifying a role. So what would we do instead? We would mock the role in the domain object. So for example, instead of calling it output, we might call it displayer. And we would pass in that displayer, and we would say the displayer should receive display with welcome to Codebreaker. And we would do the same thing in the actual code. We would implement the display object using then puts. Whatever the role that we're playing would then use puts. You might be thinking, how is this any better? Isn't this just changing words? I mean, you playing semantic games with me? No, I think it actually is better because, say, for example, you want to move from using a command line interface to using a rich GUI. Should you have to change your game object in order to change from a command line interface to a rich GUI? No, because that object is really just a role. It's the role that it's playing is displaying the information. The fact that it's using puts is an implementation detail specific to how you display the object or display the state as opposed to the actual game itself. So we should separate concerns. That way we could switch the object. If we wanted to move to a GUI, instead of using the command line puts, we would implement it doing something else. And the game object wouldn't have to know the difference. So what about testing the display object? It's like, am I just getting into a problem that this is going all the way down? Well, the Steve Freeman, Nat Price, the guys who are heavy into the London School of TDD actually say, no, in those cases, you should not write unit tests. You should not isolate that object. Instead, you should write what they call integration tests, integrating with an outside system. Or, if it's simple enough, like it probably is in this case, you can leave it to your acceptance tests. Right? You could write an end-to-end acceptance test using something like Aruba to test the command line interface, and it's going to verify that that code on the edges of your system is actually doing the right thing. And the reason why they say that is because if you are mocking an object that you don't own, you don't get any design feedback. It's not representing a role inside of your system, and so necessarily you will have to couple that object, or couple that message that you're sending to the implementation of how you are currently using it. Instead, we want to keep that implementation outside of our domain objects and test those borders independently in integration tests if you need to, or just let your acceptance tests handle it. Okay, last principle. Mock peers and not internals. This is another thing that gets people into a lot of trouble. It's something that actually has only begun to be articulated a little more recently. Mock objects have been around, I think, since the 90s. I think that this distinction only came about in the Growing Object-Oriented Systems Guided by Tests book that I talked about. And those are two references. And the basic idea is this. You need to decide what is inside and what is outside of your object. When TDD becomes a design process, you have to ask yourself, does this implementation that I am talking about belong internal to my object or as a collaborator of my object? And the key thing to notice here is that not everything belongs to a peer. You can't just infinitely delegate things out. There has to actually be some domain logic contained inside of your domain objects. And not everything inside of there, if you use objects, has to be mocked out. The key question you want to ask yourself when you're thinking about, do I push this outside of my object or do I stay inside of my object, is this implementation that I'm doing, is this the role that I am supposed to play as object XYZ? If it is my role, then I'm going to make that internal to my object, even if I use other objects. And I am not going to mock that, because that is going to be an implementation detail of how I play the role that I am going to play. So for example, I'm actually taking out of the Growing Object-Oriented Systems Guided by Tests book. They actually build a whole auction bidder for you. And this is one of the beginning parts of the system. They have an auction server that sends messages into the system, and it's sending it in some form of a string coming down over a socket, I believe. And it calls process message on this auction message translator object. And the role of this auction message translator is to translate the message that comes in from this string into the language of the domain. That is, different types of messages come in, and the translator translates them into domain terms, into the way that it talks to the APIs internal to the system. And so this would look something like this. Describe auction message translator. It notifies bid details when a current price message is received. And it has a role of an event listener, and it says the listener should receive current price with 192 and 7. That 192 is coming from the current price, and the 7 is coming from the increment, how much it changed by. The basic idea is this is coming down from the server in a string, but when you're working internal to your objects, you don't want to have to know about that string. All you care about is whatever the current price is and whatever the increment is. And so the way that they do this is they say the message translator, when it receives a message with SOL version 1.1, event price, current price 192, increment 7, bidder someone else, should send a message into the system saying the current price is now 192 and changed by 7. Make sense? And then the way that they do this is they have an auction message translator that processes the message by saying, unpack event from this message. If the event type is closed, you're going to send the message auction closed. If the event type is not closed, send the current price with event, current price, and event.increment. That's pretty semantic, I think, inside of the process message. But the key thing to notice, how do they do that? Well, unpack event creates a new object called the auction message event and passes in the string. And then they create a nice API that they're going to work with so that they can just say event.type instead of having to extract that out of the string. And they can say event.currentPrice, event.increment. This is essentially creating an immutable value object from the string that came in from the server. But you'll notice, if we go back and look at the tests, there is no mention of this object, this auction message event. They're not stubbing it. They're not mocking it. Why? Because it's an internal object. It's an implementation detail about how they are doing what they are doing instead of what they are doing. And so not every object needs to be mocked. Not every object needs to be stubbed. Don't mock this. Don't stub it. Why? Because it's an implementation detail. As that string changes, the thing might change. And you end up getting very brittle tests when you start stubbing these things. It's better to just execute the code as a black box. And when it changes, or when the requirements change, you add more tests, you change the inside, but the tests don't need to know about it. The tests respect the encapsulation of your code and test it from the outside of the system, not inside. Okay, so further resources. I'm going to tell you there is one that I would recommend anybody who is interested in this pick up, and it's Growing Object-Oriented Software Guided by Tests. Yes, it is in Java. But Java in many ways is the lingua franca of a lot of object-oriented design and a lot of TDD. A lot of this was developed inside of Java, and if we're going to be craftsmen, if we're going to be professionals, we need to learn to read Java, even if we don't write Java. So I would recommend highly that if you're interested in this, pick up this book. I learned a huge amount of things by reading it through. And I think that that's about it. Are there any questions?
How would you recommend, or tell me if this fits into what you described, mock should be good for? We're testing, we have a client who has an API, and we do not implement, we just have to use it. But we need to know, we don't want to have to actually hit the API for real in a test. Do you think that would be a good case to use a mock to say, when we give them this message, we expect this response from them?
So I think the key thing to notice is you're not really doing a command there. You said, when we send it this message, it gives us this back. So that isn't really a mock. That's a stub. And so we want to be careful with where we use stubs because we are coupling it to an implementation. But I think that one legitimate use case to use stubs is so that you don't hit a real server. I do find it helpful to at least have some tests that run against the real thing, though, so that I know if they broke it. Generally, those I would consider like integration tests. So you can definitely feel the notion of a role inside of an interface. Steve Freeman, though, has a lot of his original background is in Smalltalk, which is where a lot of the design philosophies originated. The way I tend to think about it is my mock objects are actually defining that interface. And so even though the language construct does not exist, I don't view that necessarily as a bad thing, because I think it actually is a little cleaner. Inside of Java, you have to specify that interface both in your production code and in your tests. And so you end up having to refactor both your production code and your tests when you want to change the role or the message, maybe for design reasons or for whatever. I find that to be actually a little easier and clearer to do in a dynamic language, because then I only have one place where it actually is specifying that role, which is inside of my tests.
Are you heavily mocking your shell now? Or?
Am I?
Do you mock everything now? Or?
Yeah, so my design style has become very mock-driven. I think I would subscribe to what Michael Feathers calls the London School of TDD, because I found that it produces a better design system. It doesn't mean I mock everywhere. There are some places where it makes sense to do assertions on state as opposed to doing assertions on, instead of doing assertions on the messaging between the objects, on behavior. So like maybe if that underlying object, which is an internal peer, the logic became very complex and I wasn't satisfied with just treating it like a black box, I might write unit tests for that object that just tested the responses coming out of it, and I would use state for that. But generally, I tend to think much more in a tell, don't ask style.
Can you talk a little bit about how you do this when you refactor code? When you have a class that's overloaded with responsibilities and then you extract that out?
Sure. So one of the things that is difficult is when you come into, so I guess I should repeat the question. The question is, how would you refactor something from using heavily state-based tests to a more mock-based tests? And I think it can be challenging because you're not just changing the way you test, you are changing the way that you're changing the entire internal implementation of your code. It's kind of like you're going from a procedural-oriented place where you're getting information and then making decisions based off of that information to a telling. The thing that I find to be the most helpful is actually having an end-to-end test suite, something like Cucumber or some acceptance tests that I can turn off the unit tests and try the refactor, like rewriting it. The other resource that I might point you to is Michael Feather's book, Dealing with Legacy Code. Doesn't address that topic directly, but he talks about how would you inject an interface. In his purpose, it's kind of sprouting an object for cleaning up legacy code, being actually able to test. But I find some of the same techniques apply. You just have to be careful breaking the dependencies. Any other questions?
In your example, you used like a display object that you made instead of puts inside your class.
Yes.
When would you just straight up go with puts inside your class, or should you always create a mock object?
Sure. So the question is, in my example, I created an object to do the display instead of just using puts inside of the object. When would I make an object versus just using puts inside of the object? I think the answer to that question for me generally is whenever I would write tests for it. Something that is simple enough and small enough of a program that I'm not worried about maintaining it, it's just a script. I would put those things inside of an object. I probably wouldn't write unit tests for it. I might write an end-to-end acceptance test and just kind of treat the whole system as a black box. But when I personally get into the situation where I know I'm going to incrementally build this system over time, and I'm going to have to maintain this, I'm going to want to have a strong separation of concerns and stuff like that, that's when I would do the sort of mock create an object. All right. Well, if you have any other questions, feel free to come and talk to me. Thank you very much for coming.